Are you tired of mysterious database slowdowns keeping you up at night? It's time to stop adding expensive hardware and start looking under the hood. In just 30 minutes, the Non-Techie's Guide to Azure SQL Performance reveals how to crush the performance skew and stop data gridlock in its tracks. We will activate the internal black box flight recorder to eliminate plan amnesia, organize the messy data closet causing deadly deadlocks, and learn to write instructions so clear the database runs blazing fast. Don't settle for a sluggish system. Watch this complete course right now to get the full optimization blueprint and transform your database into a performance engine. Let's get started. Think of your huge database like a giant library filled with millions of databooks. Users check information in and out by running complex queries. They're questions to the system. In every library, a few heavy-lifting queries consume most of the energy. Optimizing those few brings relief to the entire system. When writing queries, remember the two styles. Imperative code is a micromanaging boss, giving step-by-step instructions. Declarative SQL is like ordering a medium-rare steak. You say what you want, and the engine figures out how to cook it. That's where the intelligent optimizer steps in. Like a GPS, it tests routes, calculates cost, and picks a good enough plan. That plan gets stored in the plan cache. But watch out for pitfalls, like cache amnesia after a restart, or a poisoned plan that works for small requests but cripples big ones. Historically, databases suffered from amnesia because the standard plan cache wiped clean on every server restart. Enter the query store, your database's persistent black box flight recorder. It features 3 vital compartments: the plan store to remember the route, the runtime stats store to track speed and fuel, and the wait stats store. Now, you can easily rescue sluggish regressed queries and pinpoint massive resource hogs instantly. Remember, never turn the query store off. It is exactly like turning off your car's dashboard to save battery while the engine starts smoking. Ever wonder why fast databases suddenly slow down? It is usually just traffic. Databases use cooperative multitasking, meaning tasks politely wait for shared resources, which creates wait statistics. To keep your data perfectly accurate, the system uses locks, which can cause blocking. Sometimes this turns into a complete deadlock where neither task can move forward. When this happens, the database acts as a referee, canceling one query so the other can proceed. You can prevent this gridlock by keeping your data neatly organized in separate tables, like a tidy closet, and balancing your transaction isolation levels. Ever wondered how a database stays healthy and lightning fast? It starts with peering inside safely using dynamic management views, or DMVs. Think of DMVs as virtual, read-only dashboards that let administrators check vital signs, like current transactions and resource consumption, without risking a system crash. But to actually make queries fly, you need the librarian's ultimate secret: indexes. Instead of forcing the database to perform a table scan, which is like reading every single page of a 1,000-page textbook just to find one word, an index lets the system jump straight to the exact information it needs in seconds. Just remember, optimization is a balancing act. While indexes speed up reads, having too many makes adding or updating data incredibly slow. Finally, for massive analytics, bring in the heavy machinery: column store indexes. By compressing data into columns rather than rows, they allow the system to process millions of analytical records in a fraction of the time. Is your database running slow? Before adding expensive hardware, analyze your code. Poor queries force your database to work twice as hard. Stop the filing cabinet problem of making multiple trips to read data. Use efficient joins instead for a single-trip solution. Avoid a shrouded sarg where function wrapping blinds your index, forcing grueling table scans. For real performance, study the execution plan map to find bloated pipelines. Make controlled changes, test safely, and write clean, declarative instructions. In this course, we explored how the Azure SQL Optimizer generated cached query plans to handle the performance skew of top resource-consuming queries. We enabled the query store, which acted as a permanent black box flight recorder that persisted historical plans, runtime statistics, and wait data even after database restarts. We diagnosed critical traffic gridlocks, including excessive lock blocking and complex deadlocks, resolved through proper data normalization and appropriate transaction isolation levels. Finally, we troubleshooting using diagnostic dynamic management views, optimized both traditional row version and analytical column store indexes, and cautiously refactored expensive query constructs into efficient joins.